Hey, everybody. Welcome to the November 7th, 2022 Steeltoe community meeting. Let's go ahead and get started right away. Just jumping in case you haven't heard already, Spring One is going virtual this year. So we will not be meeting in person in San Francisco in December. What exactly is happening with the .NET portion of that, I think, is to be determined. We might end up splitting it out into another .NET Beyond conference, similar to what we did last year. Look forward to more information on that coming soon. On a completely different note, sorry, did somebody say something? Okay. On an unrelated note, Hystrix is going to be moving to maintenance mode. It's been pretty much feature complete for quite some time. We're not looking at abandoning it, but because it's been quite stable and we have no further plans for improvement, we're going to keep it around, but officially be doing less with it going forward. If you are impacted by this decision, please reach out and let us know. If you have concerns, if there's anything specific killer features about Hystrix that you absolutely love and don't want to lose, let us know so we can understand more about your use cases and figure out a better path forward if there is a different one other than maintenance mode. As far as upcoming releases that we've got going with Steeltoe, we've been working on the 4.0 release for 5 or so months now. We're still got a lot of more maintenance to do, a lot of internal updates. If you do want to get a pre-release build, find us on the community Slack or on GitHub, and we can get you access to the CI builds to see how that's going to affect your applications going forward. We are changing package names again. We should be simplifying the packages that we produce, so there's fewer of them, and the naming should be a little bit cleaner. We're also reducing the API surface area, not so much because there's too much out there that you're definitely going to use. It's more just some cleanup, some stuff that was probably public that didn't need to be. With the reduction of this API surface area, it should reduce maintenance burdens going forward. We're also doing a lot to work on Kubernetes compatibility. Later on, we'll have a bit more content about cloud native binding support specifically. We're also doing a lot of work around actuators and updating how they interact with, or how they map with Spring actuators. Make sure that the shape of those responses is consistent. We also have a patch release in progress for Steeltoe 3.2. There's some minor content changing there, mostly just bug fixes. This link will be available in the YouTube video, so you can go ahead and click that. You can click through and get to the definition of what's in these releases so far. Also happening this week, .NET Conf is happening right now, so I'm sure some of you are watching that. Otherwise, go back and check the recordings. There should be a lot of great stuff happening in there. In preparation for Spring One, Dave Tillman had been working on some RabbitMQ Steeltoe stream-related workshops. Dave, you want to chat about what's happening in those, what inspired them, and where they live right now?
Yeah, so we decided to do a bunch of tutorials for RabbitMQ and Steeltoe support for RabbitMQ, and decided what we would do is mirror what the Rabbit team had done. Here, let me share my screen.
Sure.
Find it. And you should be able to see the RabbitMQ website, the tutorials. So they have developed 7 tutorials that go from a basic hello world all the way up to something a little more, and they get a little more complicated along the way. And they illustrate several of the features of the underlying RabbitMQ broker. And if you look at this, you see that there are several both language and library bindings that they do examples with. So for example, there is a C# set of tutorials that go with each one of these that drop down to the lower level APIs that you can use to interact with the broker. There's also, if you look, Java, straight Java client APIs, as well as the what's called the Spring AMQP library. And the Spring AMQP library is built on top of the Java library, and it adds abstractions on top of the Java APIs that just make it a little easier to work with RabbitMQ in a Java application. And so what the Steeltoe team did is we essentially did a similar implementation as the Spring team did for Spring AMQP, where we took the underlying C# libraries and we built on top of the abstractions very similar to this, what the Spring team did. And so what I've done is I've basically gone through and created tutorials for each one of these. There's seven in total that pretty much match the Spring AMQP type mechanism. But of course, we did things differently because it is a little bit, I mean, because we are in a .NET space. So the APIs and the way in which you interact with things are a little bit different. The code for that, I just pushed that up. And this was, we were going to do this as a tutorial as part of Spring 1 this year, but that has all kind of been changed. So the code for that is over in the samples repo right now. There's a branch, I just pushed it up yesterday, that if you go under the messaging directory down into source, where we have various other samples in here, there's now a new folder called tutorials, and this is on the RabbitMQ tutorials branch. Eventually it'll be merged into here, or maybe even into Steeltoe IO. I'm not sure exactly where. But if you click down in here, you'll see then the directory with all 7 tutorials. And if you click into one of them, you'll see they're all pretty much structured the same, pretty much following the same stuff that is already out there for the Java and the Spring ecosystem. There's a receiver and a sender, and then there's a solution file that, and then a README that walks you through how to basically get up and running. And it's a like I said, a tutorial, so it gives you some of the basics of RabbitMQ, things like obviously queues, as well as exchanges and routing keys and bindings and all those sorts of things that are kind of unique to Rabbit, and how we expose those in using Steeltoe. And so just to quickly, I'll just take a quick minute here and we'll take a look at, for example, let's drill into the very simple hello world receiver. We first of all illustrate, if we look at this code, we illustrate that we've built a RabbitMQ host component that very much mirrors the generic host component in .NET Core. And you're able to use that. And what it does is essentially create the service container with all the Steeltoe components that you need in order to interact easily with RabbitMQ. And in the first tutorial, we kind of explain all of those components. If you take, for example, there's a underlying caching connection factory that is added to the service container that all the other Steeltoe components use in order to obtain connections and channels to the RabbitMQ broker. And it's done in a way to cache those connections because of performance reasons. And then the way in which you can, for example, and then there's a bunch of other components as well. There's which I'll show some of that. There's one that's called the Rabbit. I'm sorry, the Rabbit admin component that Steeltoe adds to the service container. And the Rabbit admin component essentially at startup time looks for any RabbitMQ entities, things like queues, exchanges, whatever, that have been added to the service container. And the Rabbit admin component, upon startup of the application, will go out and try to declare those queues or those exchanges or whatever. So here we show how there's an extension method that you can use to add a queue with a particular name into the service container. And then again, at startup time, Rabbit admin will pick that up and go out and actually declare that queue for you and get it all set up so your application or applications can make use of it. And then this particular sample here is the receiving side of a RabbitMQ application. And so we add a singleton into the service container, which is the receiving component. It's called toot1 receiver. And we declare it, we tell Steeltoe basically right here that we want Steeltoe to recognize toot1 receiver to be a Rabbit listener, meaning it's going to listen on a queue or listen on some endpoint and process messages coming off that queue. And so if we go then take a quick look at the toot1 receiver, we see that it's a very simple class. We inject a logger so we can log it. And then we use this annotation or attribute called a Rabbit listener. And we essentially say, by doing this, we're saying this method called receive will process all incoming messages that are put on the queue with the name queue name. And behind the scenes, Steeltoe spins up something we refer to as a Rabbit container, which is essentially, think of it as and it's not to be confused with a Docker container or something like that. It's a bad use of words, but that's how the Spring team refers to it. And essentially, it sits in the background and handles all the details associated with interacting with the RabbitMQ broker. So setting up a basic consumer, handling any failures, et cetera, and in fact, translating whatever the byte stream is that's coming in off the queue into some sort of object. In this case, it's a string, simply a string, but it could be a complex object. And it will go ahead and do the conversion of the data byte stream from, say, JSON or whatever the marshalling technology you're using underneath, and convert that into the object and then invoke this particular method. So this is just one example of a very simple example of interacting as a receiver. And then if we go over here on the sender side, we essentially what we did here is we again used the RabbitMQ host component from Steeltoe, create a builder, and then configure the services. We add the queue as well into this container. Again, the Rabbit admin will notice that queue and will actually try to go out and declare it. If both applications, the receiver and the sender start up, one will get there first and declare the queue, and the other one will just move on and not do anything. And then we add a hosted service. In this case, we did a background service as the sender, and we implemented the background service as toot1 sender. And so if we take a quick look at toot1 sender, we can see it is a background service. In this case, what we do is we inject what Steeltoe refers to as a Rabbit template. Think of this as an abstraction on top of, again, the RabbitMQ client code. And this Rabbit template has been pre-configured using the caching connection factory that I mentioned earlier with a proper connection to the RabbitMQ broker. And when this method here gets called, execute async in the background, we use the template to basically send a message, in this case, just a simple hello world string, to the underlying RabbitMQ broker that this Rabbit template has been completely set up to interact with. And we wait for the response and just log it. And so this is a simple hello world. And so this background service just runs every, I think every second, and sends a hello world text string to the receiver. And then if we go through the rest of the tutorials, we get a little more complicated. We show some more features of Steeltoe. Let me pick 3, for example. In 3, if we look at the receiver, again, the structure of them are all the same. We take a look at program.cs, same sort of thing. RabbitMQ host is used again to configure services. At this point, notice that we didn't use the add queue method, for example, to add a queue into this receiver. All we did was add the Rabbit listener component into the service container. And in this example, I think I introduced the use of annotations or attributes to actually declare the RabbitMQ entities that we want RabbitAdmin to go ahead and configure. In this case, I think we're declaring essentially an exchange, and we're giving it a name called .fanout, and it is a fanout type exchange. So we're declaring this exchange. Then we're declaring two anonymous queues with the names Q1 and Q2. And then we're declaring what's called a binding between the queue and the exchange. So the name of the binding is this big long name. It could be anything. It's just a string. And then this name here, of course, .fanout1 matches this particular exchange. And then this syntax here is a way in which we reference this anonymous queue. This is using what we refer to as an expression language in order to access objects out of the service container. So expression languages start out with a pound and then in braces followed by the actual language syntax itself. In this case, the @ symbol says, I want to reference something out from the service container that's running in the back, that's been established in the background. And what this is it's essentially referencing a service with a particular name, and that service is actually this anonymous queue called Q1. And so this ends up obtaining this Q1 anonymous queue out of the service container, and then uses the name associated with it to tie that to the queue name. So it's just a expression language usage that you use to bind these things all together. So when the RabbitAdmin is started inside of the service container, it notices all of these RabbitMQ entities here, and essentially goes to the broker and creates and declares all these things for you behind the scenes. And then in this case, we have this particular class is listening on two queues. So we've got two methods here, receive1 and receive2. And again, we're using this expression language to say whenever messages come in on Q1, call this particular method, and whenever messages come in on Q2, we'll call this particular method. And all it basically does is log some things and so forth. So it's basically illustrating, like I said, several of the Steeltoe features for RabbitMQ messaging for users. And then the last, we'll take a quick look at sender. And in this case, again, program.cs, very simple. We just add the background service into the service container and take a look at sender. We again inject the Rabbit template into the constructor and go ahead and create a message. And we're essentially using the same method on the Rabbit template, but this time now we're sending it to the exchange with no routing key and sending the message basically, again, using the same Rabbit template features that we mentioned earlier. And so anyway, we've got 7 tutorials. If I go back to here, they're all kind of everything from the one I was just looking at was the tutorial 3, which is a pub/sub type application where we've got an exchange sitting in front of 2 anonymous queues and the 2 consumers, in this case, the 2 receive methods that I pointed out earlier. We go down to actually using something called routing keys. So here's how to do that. If you want to use topics, topic exchanges, got an example there. You can actually use RabbitMQ to do a RPC mechanism, request reply mechanism, and we've built all the componentry to make it really easy for developers to actually use RabbitMQ as an RPC mechanism. And then the last thing that we did is we did the publisher confirms. This is a way in which the client, in this case, the sender gets back essentially a confirm that the actual message that you have sent to, say, an exchange or a queue has actually been accepted and potentially saved in a reliable way on the broker. And so this shows how the callback, it's an asynchronous callback, how you can make use of that with Steeltoe. So those are some of the features that the tutorial that we pulled together illustrate. And like I said, we're either going to keep this code here in the samples repo for people to grab and take a look at, or we talked about possibly putting this in Steeltoe.io as part of some of the documentation and kind of grabbing it and putting it over there. So that gives you an idea of what we've done.
Awesome. Thanks, Dave. One quick question. You mentioned RabbitMQ or RabbitAdmin a bunch of times. Is that's being added by the RabbitMQ host?
Correct.
Is there more that the RabbitMQ host is doing that we should know about?
Yeah, there's several things. So there are two components: Rabbit template and Rabbit admin. These are two components that are added for you and are available for you to inject into any component that you want in .NET. They have APIs on them, those two things, for sending and receiving messages to the broker. And then the Rabbit admin has methods on it that are like declare queue, declare exchange, things of that nature. So you can grab those and make use of those. And like I said, they come pre-configured with a caching connection factory. I'm sorry, with a connection that's produced by the caching connection factory, which is also added to the service container. And the caching connection factory is used by all the Steeltoe components, and you could use it yourself if you wanted to in your own code. And essentially it caches the connections and the channels that are used for communicating with the RabbitMQ broker. And it also comes out of the box by default, it comes pre-configured to use localhost and the default 5672 port that the RabbitMQ broker listens on for clients that want to connect to it. But you can customize it and configure it to connect to whatever you may want. And then there's several other components. For example, there's what's called a message converter component. There's a default one that's added to the service container that is used to translate all byte streams that are coming in from RabbitMQ or going out to RabbitMQ, translate all objects that you might have into a format, for example, JSON, or as a default, we actually use the .NET serialization engine right now. And it's able to do some really sophisticated conversions from objects into the byte stream that's sent across the wire and vice versa. And in fact, one of the things that's built into it that's important for some customers is that the way in which we marshal that data from, say, a .NET application out onto the broker is compatible with the Java Spring Team's implementation of that. And so you can easily send objects from, say, a .NET application to the broker and have it consumed by a Java Spring AMQP type application or vice versa. So we, out of the box, try to provide easy interoperability between those two worlds. Some other components, let me think. There's, like I mentioned, there's this container that you really don't even know exists, but it's think of it as a Steeltoe component that essentially acts as a consumer for whatever that Rabbit listener has been defined to do. And so it gets spinned up, it gets started and sits in the background and handles all the interactions with the RabbitMQ broker. So that when a message comes in off the queue, this container, this thing that's sitting in the background, takes it and applies the message conversion componentry to it, and then invokes the Rabbit listener method kind of behind the scenes. So all of that plumbing work that you would normally have to write as a developer, handling exception conditions, what happens if the connection goes down, the container manages all of that for you in the background. So as a developer, all you really have to worry about is writing that single method with the right signature, and behind the scenes, the container takes care of all the gory details of calling your method. So those are some of the things that are added. There's various other componentry behind the scenes that are added as well, but you're less likely to probably interact with those as a developer. So.
Okay, that sounds great. Thanks for covering all of that. I think the next thing we have up on our agenda for this morning is cloud native bindings. I can tee that up with an intro, or if you want to just tackle the whole thing.
Yeah, so there's I think what you're referring to is the service binding stuff that for Kubernetes that has been it's being promoted by VMware and other companies, and so yeah, so we have started the implementation of that. They're basically what it's turning out to be, and there's actually a branch up in the Steeltoe repository where we've done essentially a port of that, and of that what the Spring team has done. We're looking for compatibility with Spring team's implementation as well. But essentially, it's a configuration provider that reads the so the way service bindings are presented to an application on Kubernetes, and this by the standard, is think of it as like a directory structure that is available to the application. And oh, thank you, that's great. So there's a spec out there if you want to go take a look at it. And essentially, the directory structure represents the key, the directory structure, along with the actual file at the end of the end of that structure, represents the key for a service binding, and then the contents of the file is the actual value associated with that key. So we've essentially implemented a configuration provider that reads this directory structure as explained in this spec, and turns that into configuration values. And they're all prefixed with in the same way that the Spring team has done it, with Kate's as the top prefix, followed by, I believe, I can't remember off the top of my head, I believe it's maybe binding or service binding, followed by the name of the service binding, I think, followed by the rest of the keys of some sort. And I think that's kind of how it was done. And those get populated inside of the configuration, the iConfiguration root, and then we have this component that acts as what we refer to as a post processor, that essentially takes those incoming service binding keys and then turns those into essentially other configuration values that are specific to Steeltoe, and which then would be mapped to options classes that represent the service bindings. And then the next step after that, and that's kind of where we are, we haven't quite finished that part of it, the options classes yet. But the next, and that's optional, by the way, the part that transforms the Kate's configuration values into these other values is an optional thing that's not even turned on by default. And then the next step after that is to define all the options classes in Steeltoe that will capture all these various service bindings. There's actually several of them. There's like 20 of them, I think, or more out there. And then once we have all that, then the next thing is to tie that into the connectors functionality, and so that you'll be able to essentially make use of our connectors kind of features. But we're going to do some refactoring of that whole space because of it's evolved into kind of a mess over there for us, and we need to clean that up for 4.0. And so that'll be the next step. So bottom line is work is underway, and hopefully we can get back on that here going full bore. So
Excellent. Thanks for covering that, Dave.
okay.
I think that concludes everything we have on the agenda. Any other final notes from anybody or final topics? Okay, thank you very much for your time, and we'll catch you all later.